Hi everybody, welcome to the first week of the Math Methods seminar. A little bit of background on me. Been tutoring general maths for like 15 years now, and decided to take the plunge into math methods. Why? I don't really know, just out of interest and job prospects. There's not many specialist maths teachers and math methods teachers around, so I thought, why not? And basically this one's going to be fairly low key. Be getting to know you guys, seeing how your brain works. I've got a couple of questions I want to throw at you guys to see how you would answer it. Mostly just so I get a gauge on where everybody's at. And we'll go through some geometric and arithmetic sequences. So that's unit 1 for grade 11. Again, it'll just give me an idea of where everybody's at. If you're watching the recording and you're going through it and you find it really comfortable, please email me, say, hey, that was easy. It should be fairly simple for the grade 11s. The grade 10s, it might be a bit of extension, but again, it just depends on where you're at and how your brain works. We've got mostly grade 10s, but a few grade 11s as well. You guys are doing effectively the same curriculum. The pre-methods for grade 10 is kind of a watered down units 1 and 2. So I'm just going to put this question up. And actually, no, I'm going to ask, so what the guys that are here, Henry, Tyler, and Molly, why are you doing math methods and not general maths? What's the reasoning behind them? Any specific reasons? You can type it in the chat if you want as well. Anyone? So I imagine some of you are wanting to do medicine, methods being a prerequisite. So Molly, I know Tyler wants to do medicine as well. How are you guys finding methods so far? What is, I guess, your pinch points? And if you're watching the recording of this, please answer the questions and just email them to me. So why are you doing methods? What's the reasoning? What are you struggling with? And you know, what would you like assistance with? Because I would rather tailor this to you guys as well. I've got my own ways of doing things. I've effectively taught myself to do this. So I have some weird and quirky ways, probably a bit different to your teachers. I won't be doing too much talking today. I'll probably do an extra, probably 2 recordings like I normally do, usually with some exam prep or some extra questions for you guys if some of the sessions don't quite make it out. So what I want everyone to do is to have a look at this question and just have a go at it, or even have a think about it. The answer is a lot simpler than you think, but it starts to get you thinking in terms of sequences, whether it be geometric or arithmetic. I just want to see how everybody's brains work. So if you are watching the recording, please send me an email with your answer. And I might answer it this time, or I might answer it next week and give everybody a chance to have a go at it. So we've got this question here. You've done sequences and you're in. So again, this is just for me to get an idea of where everyone's at and see how everyone's brain works. So I'm going to give everyone, if you're watching the recording, you can either sit there and try and figure it out or go forward a couple of minutes. Yep, so Henry says it's a geometric sequence, but what formula could you create to solve this problem? This one stumps a lot of people. It's much simpler than you think it is. If you've not done the geometric sequences stuff, that's fine as well. But it's I just want you to have a go. I don't care if you get it wrong. Yeah, Henry, we could do that. I'm thinking simpler. So we're looking at sequences and, sequences that effectively never end. So Henry said AN equals A1 plus DN minus 1, which is one way you could do it. I would just have, actually I'm going to give everyone that extra minute to calculate. Henry, are you in grade 10 or grade 11?
I'm in grade 10, but I'm doing grade 11.
Okay, cool. So you probably got a bit of a head start on the year 10s. My way of doing it would be AR to the power of H, or the amount of bounces, or sorry, not H, N. So you have 2 times 0.6 to the power of, in this case, it would be 3. That would allow you to calculate simply the height of the ball at any bounce. So after 1, 3, 7, eventually we'll get to 0. Extension homework, an extension question. So I'm actually going to put up the, so they're not all going to be like this. They'll mostly be me talking and you guys working with me, but I'm just trying to probe where everybody's at this time. So that's, can you all see the answer there?
Yeah.
So that's how I would figure it out. That's a simple way for doing a arithmetic sequence. Depending on the complexity, so that's a geometric sequence, not arithmetic. Depending on the complexity, you can use that formula. Bonus points, if you want to email me the answer. How could I rearrange that formula to figure out how many bounces it would take to get to 0 meters? So bonus points question. How many, I'll go through this next week. Hopefully I remember if I don't remind me. How many, sorry. How many bounces would it take to reach a height of 0 meters? So again, I want everyone to have a go at this because it's going to show me where your algebra is at, because it looks complicated, but that should be a fairly simple rearrangement of that equation. So today is all about getting to know where you guys are at. All good with that? All right. Chapter 2. All right, we're going to start with arithmetic and geometric sequences. That is the start of Unit 1 in grade 11. So the grade 10s next term, this is what you'll be doing. The grade 11s, this will be really good revision. You should have a data test coming up at the end of this term, depending on your school, where you'll be looking at arithmetic and geometric sequences. You will look at it from a finance perspective, so simple and compound interest. You'll look at it from decay, so linear decay, so modeling half-lives of things, depending on your teacher and your school. But we're going to go through the basics of it today, maybe 20, 25 minutes worth, just using the textbook here. Any of the questions that I'm asking and you can't answer, or you think it's too easy, or I'm going too easy on you, please let me know. This is all about trying to, pardon me, figure out the best sort of mixture of stuff and the mixture of difficulty for everybody in the group. I've tried to keep it small. There's only 7 of you. So we will try and keep it to everybody. Okay. Anyone know the difference between an arithmetic and a geometric sequence?
The arithmetic is like where it's plussing or minusing by the same time, like by the same amount each time, and a geometric's when it's increasing.
Yeah, so arithmetic is the same. Geometric can go down as well, but it's at a different amount each time. So arithmetic would be like 1, 3, 5, 7, 9. And a geometric sequence would be something decreases by 20% at each time point from 10. So you would go 10, 8, 5.6.4. Now testing my math skills. And you're going down like that. So it's still going down or up. Either one can go down or up. You can have a negative sequence or a positive sequence. But arithmetic is a linear sequence. So you'll get a nice straight line. Do we know what the other kind of line is when we're looking at graphs? We've got linear and anybody? Oh. Quadratic. We've also got logarithmic. So you'll get what they call with a geometric sequence, you'll get a J curve. So when you're doing a lot of your modeling, I don't know, Henry, if you guys in grade 11 yet have done your flu outbreak modeling, or I think Tyler, you might have done that. So that's going to be a logarithmic, whereas arithmetic is going to be nice and linear, and straight. So again, what I want you guys to do is 3 minutes. Again, this is probing where you guys are at. 3 minutes, tell me as many of those, are they arithmetic or geometric sequences? And I'm using the year 12 general maths textbook for the arithmetic stuff because it's at about a grade 10, 11 methods level. But you guys go way beyond this when you get to grade 12. So Henry says 1 is geometric. Yep, so 5, 6, 8, 11, 15, 20, 26. It is not a linear increase each time, or it's not increasing by the same amount each time. And if you're really wanting a challenge, say what the change is. So the first one, geometric, it's going up. Each change is going up by 1 more than the previous change. So we have 5 to 6 is 1, 6 to 8 is 2, 8 to 11 is 3, 11 to 15 is 4, so on and so forth. So each change you would have n plus 1. Second one, we've got adding 35, then we're what? Go to 26. Third, geometric, we are doubling each time. 29, 27, arithmetic. 29, 27, 25, it's going down by 2 each time. Anybody pick the trend here? So we got 1, 3, each time you're adding more than 1 each time, so the same as question as number as A. What about this one here? So the geometric sequence, it's reducing by half each time. So have you guys heard the term recursion relation, that kind of thing when you're looking at modeling? No. Okay. So again, so we're going to look at finding the 8th term. Now, start with, you can manually calculate this. So 5, 9, 13, 17, 21 is the 5th, 25 will be the 6th, 29 will be the 7th, and 33 will be the 8th. Do you think there's an easier way to do this than just counting?
Yeah.
So what have you learned what to use, Henry?
There's the formula. I'm just trying to think of it. It's like T and something.
Instead of sitting there and calculating it every single time and going, because we might be able to calculate the 8th term, but what if we want to the billionth term or the trillionth term? We couldn't sit there and calculate it. And this is the sort of differentiation between general maths and math methods as well. You learn how to do everything automatically rather than sitting there. So if I find the equation down here, should be Tn equals T1 plus n minus 1 to the power of d. Is that the equation you were looking for, Henry?
Yeah.
Yeah, so this is how we can find the nth term of a sequence at any number. So it could be trillion, could be billion. So the general rule for the nth term, or it doesn't matter what number, we put it in there and we sub it into the equation. If you want to write down this equation, you can tattoo it onto your forehead backwards because you will use it a heck of a lot. You can hear a dog whining because she's very lonely. So we can calculate using this form or the general term of an arithmetic sequence. What kind of things can we use to model with an arithmetic sequence, Henry? No?
You can use it to do. You can use it to do interest. Interest,
yep.
Compound interest.
Do compound interest, yep. So financial maths, again, that's something you'll do in grade 11. If you're in grade 10, you're looking at the grade 11 and 12 curriculum for methods and general. What you do in general in grade 12 is like a weak version of what you do in methods in grade 11. So you'll go a fair bit more in depth in this, but I'm just wanting to go over the basics today. So everybody got that down? T1 being the value at the first time, n being the number minus 1, d being the difference. You can use this with geometric sequences as well, but we'll stick with arithmetic. So this is asking us find the sequence with the first term 6. So T1 is 6. So we're going to write I'll get another piece of paper. I can do it on the whiteboard as well. I'm going to go through it that way. Let me grab some blank paper. So on our paper, we're going to write the general formula, which is Tn, and you can see it on the screen there. So that's our general formula. Tn equals T1. So I want to get you guys into the habit of writing everything as if it's an exam, like you want to get full marks for your exam. So we start with the formula. We make sure we have the right formula. Who's done an exam with a formula book, but realized half the time they actually use the wrong formula? Me, many times. So T1 in question 1 is 6, right? We then have D of 4. And the term that we are looking for is term number 15. So I wanted everyone to take 30 seconds and put the numbers into that equation. And do we need to rearrange the equation, or can we use it as it stands? Again, if you're watching the recording, I'm just going to be sitting here staring off in the space for 30 seconds. I'm going to do this along with you guys. I'll show up my working and you can compare it to yours. So Henry's got 62. So Henry, in the chat there, do you want to type in the numbers that you sub? This is the easy bit, right? This is just learning how to sub the numbers in. Going to test your algebraic skills. So we've got T15. I'll write my equation, see if it matches Henry's, and we are. So is everybody, for that we've got T15, 6 plus 15 minus 1 times 4. Does anyone know why we put the minus 1 in? We don't want to include the first term. So that should give us 6. And again, I'm going to show you how to write this so that when you're doing your exams, you get full marks, not just half a mark for getting the right answer. So if I was marking your exam and you wanted full marks, that's how you would need to write your answer. So you've got at the top, up there, we've got the terms. We then sub the numbers in. We do the calculation correctly in the right order. And then we actually write the answer at the bottom. The 15th term is 62. So doing the best in math methods doesn't mean you're always the smartest person. It's about being smart in your exams, not the most intelligent person, sorry. Okay, so let's write out again. I'm gonna waste a lot of paper, I can just see it. I could use the whiteboard, but that would take the example away. So we've got the next question. We've got, what's the difference for B? Anybody that isn't Henry? Tyler or Molly? What's the difference here if we were going to play around with this sequence? What would D equal? You can put it in the chat if you don't have to say it. Okay, because it's going down, it's going to be a negative number. So D would equal minus 5. T1 is 28. This will get a bit gnarlier after this because we're going to start looking at where we're only given half the variables and we have to calculate the rest. And we're asked to calculate what T12 would equal. So we have D, T1, and N. So we sub it into our equation. So same as before. T12 is 28 plus 11 times minus 5. And we know from our order of operations that we would do the bracket calculation first. So the next line will be 28 plus minus 55, which would give us minus 27. All right, let's kick the difficulty up a level, make sure I'm right. 62 minus 27, sweet. Okay, now we're getting into unknown territory, even for possibly for the year 11s. But how to rearrange this equation to solve for the unknown variable? How's everybody's algebra skills? Methods is as much algebra as anything else. Henry, you good with algebra?
Oh yeah, I wouldn't say I'm like the best, but
Yeah, that's fine. So again, if you guys are watching the recording and you don't get the same answer as I do or we do, they will be different in the following weeks. I'll come up with slides and stuff like that rather than just working through the textbook. But I just wanted to not do too much speaking tonight and just get a guide of everyone's brain is at. So if you're not getting something, if something doesn't make sense, please tell me. What I also want everybody to do is just email me in what you'd like to see us work on in this. Because I didn't really make much of a plan because I know sort of everybody's going to be coming from different places, not geographically, but mathematically. And there's some grade 10s and some grade 11s as well. Okay, Henry, what are our variables here?
D equals 3.
Yeah.
But you don't know n because you don't know the term number that it is to get 300.
So we don't know n, but we do know T1. And that's 14, right?
Yeah.
So if we sub in the values to our equation, should have 300 equals 14 and times 3. If my notes are correct. Something like that, Henry? You got the same thing?
Yeah, I got the same thing.
Okay. How do we rearrange this?
I put the 14 to the other side, so I did 300 minus 14.
Yep. So we effectively swap it around. I would rewrite it as 300 n minus 1 equals 300 minus 14. That's how I would rearrange that equation because we want to get isolate n by itself. So 3 n minus 1. Because remember, when we've got n minus 1 in brackets times 3, it's effectively the same as putting the 3 on the left-hand side of the brackets. Then we can just expand. So we're going back to our grade 9 algebra now. And that's the thing with a lot of this stuff, is it's made out to be massively complicated. But a lot of it comes down to basic algebra. I mean, log laws, all of your crazy derivative stuff, sure. But a lot of the stuff in grade 10 and 11 will come back to your knowledge and skills in algebra. Sorry. Okay, Henry, what would we do next?
I divided the 286 by 3, so I got n minus 1 equals 286 divided by 3.
Yeah, so we want to get rid of the 3 on the outside of the brackets on the left. So in order to do that, we divide both sides by 3, which gets rid of the 3. So that's our next step. If you're watching at home, we've now got on our next line, we've got n minus 1, and by dividing both sides by 3, we remove the brackets as well. So we should end up with 95 and a third. N minus 1 equals 95 and a third.
Yeah.
We need one more step to get to the answer.
Then you plus that, so you get 96 and a third equals n.
Yeah, n equals
and because you want it to exceed 300, and because you want it to exceed 300, it's term 97.
So yeah, 96 would be 299, but the question specifically states 97. Has to exceed, sorry, brain not done that. Has to exceed 300. So we got 90, the 97th term is the first one. So we're going to do a couple of these just to test, not even your knowledge of arithmetic and geometric sequences, but, oh, sorry, but your ability to do algebra on quite a, so again, we'll go through this now. I think we went through it, but we need to get n by itself on the left-hand side. So we swap, we take 14 away from 300. Because we've got n minus 1 in brackets times 3, we can shift it over to the left and keep the 3 on the right, the left-hand side of the brackets. Then we just use our order of operations. So 300 minus 14 is 286. We get rid of the 3 by dividing both sides by 3, and gives us 96 1/3. So how much deeper have you gone within this so far, Henry, in your sequence stuff in year 11?
Oh, we've gone pretty deep. We had we just started unit 2.
Yeah, you would have just started unit 2 now after term 1. So you would have just finished the second part of the arithmetic and geometric sequences.
Oh yeah.
So you would have done.
But like I have like this understanding, but like the greater understanding I need to work on a little bit.
Yeah, that's cool. What I want is to get where everybody's at, and then we can start to extend that knowledge. But yeah, this is sort of the baseline of what you would need to know. Okay, so arithmetic progression, arithmetic sequence, they're both interchangeable terms. So the third, so what's the question asking us to figure out? We don't have T1 and we don't have a common difference. So how on earth can we calculate? And this is what I'm wanting to get you guys to change the way you think about questions that seemingly you can't answer them, but there's always a way. Okay. So the third term is 8. The 13th term, I'm just writing this down so you guys can see what I'm writing, is 5. So how would we begin to calculate A, the first term, and B, the common difference?